In this video I am going to talk about Eth-trunk and iStack cluster switch system. As services development and the campus network scale expands, users have increasingly demanding requirements on network bandwidth and reliability. Traditional solutions improve network bandwidth by upgrading devices and implement high reliability by deploying redundant links and using a spanning tree. And this solution leading to low flexibility, time-consuming troubleshooting, and complex configuration. On this chapter, I'll describe Eth-trunk, intelligent stack, and cluster switch system technologies to improve network bandwidth and reliability. On completion of this chapter, you will be able to understand the functions of link aggregation, understand the link aggregation types, understand the link aggregation negotiation process in link aggregation control protocol, LAGB mode, understand the advantages and the principles of iStack and the cluster switch system, understand the common applications and the networking of link aggregation and stacking technologies. At first section, network reliability requirements. Network reliability refers to the capability of ensuring non-stop network services. When single point of failure or multiple points of failure occur on a device or link, network reliability can be implemented at the card, device, and link level. At this figure, you can see network A and network B. To ensure network reliability between two networks, network A and network B, and the non-stop services, we can use link aggregation technology and iStack technology to ensure this reliability and the non-stop services between two networks. Link reliability. To ensure link reliability in the traditional solution, we can deploy multiple physical links between devices. You can see this at this figure. To prevent loops, configure STB to ensure that traffic is forwarded on only one link. You can see this port is blocked, and other link functions as backup links. This link is used to backup 4 active link in this topology. To improve link reliability, a new link will be added. This link is blocked by STB and functions as a backup link. Link aggregation or Eth-trunk solves this problem. Principle: increasing link bandwidth. When multiple links exist between devices, traffic is forwarded on only one link due to STB, this traditional solution. In this case, the inter-device link bandwidth remains unchanged. You can see we have switch 1 and switch 2. In the traditional solution, this switch is a root bridge. You can see all ports on forwarding state. And switch 2, non-root bridge, you can see this ports is blocked ports to prevent network loop. This link is active link, and other link is backup links. On the Eth-trunk solution, Ethernet link aggregation, also called Eth-trunk, bundles multiple physical links into one logical link to increase link bandwidth without having to upgrade hardware. You can see switch 1 and switch 2. When we configure Eth-trunk on these 4 links, you can see all ports has a forwarding state. This is increase link bandwidth without having to upgrade hardware. Basic concepts of Eth-trunk. A link aggregation group is a logical link formed by bundling several links. Each group has one logical interface known as link aggregation group interface or Eth-trunk interface. Member interfaces and member links. Physical interfaces that constitute an Eth-trunk interface are called member interfaces, and the link corresponding to member interface is known as member link. Active interface and active link. An active interface is also called a selected interface and is a member interface that participates in data forwarding. The link corresponding to active interface is called an active link. Inactive link and inactive interface. Inactive interface is also called unselected interface and is a member interface that doesn't participate in data forwarding. A link corresponding to an inactive interface is referred to as an inactive interface. Link aggregation modes. Based on whether the link aggregation control protocol is enabled, link aggregation can be classified into manual mode and lag B mode. You can configure link aggregation on lag B mode or manual load balancing mode. You can see on switch 1 and switch 2 configured with Eth-trunk. You can see this interfaces is the member interfaces and some interfaces selected and other interfaces unselected. We can see Eth-trunk interface we can use Eth-trunk interface number 1. This is interface called Eth-trunk 1. Manual mode. In the manual mode, all interfaces active interfaces. We can use manual load balancing mode on lag B in capable old or low-end devices. Manual mode. An Eth-trunk is manually created and its member interface are manually configured. Lag B mode is not used for negotiation between the two systems. In most cases, all links are active links. In this mode, all active links forward data and share traffic. If an active link is faulty, the link aggregation group automatically shares traffic among the remaining active links. If one of the devices at both ends of an lag B or link aggregation group doesn't support lag B mode, you can use manual mode in this condition. Defects of manual mode. To ensure the Eth-trunk works properly, ensure that the peer interfaces of all member interfaces in Eth-trunk meet the following requirements. The peer interfaces reside on the same device. The peer interfaces are added to the same Eth-trunk. In manual mode, devices don't exchange packets. Therefore, the configuration need to be manually confirmed. In the manual mode, the device can determine whether the peer interface is working properly based on the physical layer status. In this interface in up state but failing to forward packets. This is another defect of manual mode in Eth-trunk. Lag B mode, link aggregation control protocol. Lag B mode uses the Lag B protocol. Devices exchange link aggregation control protocol data units to ensure that peer interfaces are member interfaces that belong to the same Eth-trunk and are on the same device. Lag B contains the device priority, MAC address, interface priority, and interface number. Lag BDU protocol data unit of link aggregation control protocol contain device priority, MAC address, interface priority, interface number. These parameters will be used to select interfaces that will be active and forward data. We will talk about system priority. In Lag B mode, the number of active interfaces selected by devices at both ends must be consistent. Otherwise, the Eth-trunk can't be set up. In this case, configure one end as the actor, then the other end selects active interfaces according to the actor. The actor is determined based on Lag B system priority. A smaller value indicates a higher priority. By default, Lag B system priority is a smaller value indicates a higher priority. Generally, the default value is used when the priority are the same. Lag B selects the actor by comparing the MAC address. A smaller MAC address indicates a higher priority. Interface priority. After the actor is selected, both devices select active interfaces based on interface priority of actor. A smaller Lag B interface priority value indicate higher priority. By default, the Lag B interface priority of an interface is the same as system priority. A smaller value indicates a higher priority. Generally, the default value is used. When the priorities are the same, Lag B select active interfaces based on interface numbers. A smaller interface number indicates a higher priority. Maximum number of active interfaces. In Lag B mode, the maximum number of active interfaces can be configured when number of member interfaces exceeds the maximum number of active interfaces. The interfaces with higher priority and the smaller interface numbers are selected as active interfaces, and other interfaces function as backup interface, unselected inactive interfaces. In addition, the links corresponding to active interfaces become active links, and the links corresponding to inactive interfaces become inactive links. The switch sends and receives packets only through active interfaces. You can see in this topology we have two active interfaces. Interface number 1 and interface number 2 is active links. The data forwarded through link number 1 and link number 2, and other links is inactive are inactive interfaces, link 3 and link 4. Maximum number of active interfaces: if an active link fails, an inactive link with the highest priority based on the interface priority and interface number is selected to replace faulty links. This ensures that overall bandwidth doesn't change and the services are not interrupted on your topology. You can see switch 1 and switch 2, we have error with link number 2. You can see link number 3